In this final video on regression lines, we're going to talk about how to assess the strength of a relationship by looking into the residuals, the coefficient of determination, as well as the correlation coefficient. So if we start with the correlation coefficient, this is a numerical measure of direction and strength of a linear relationship between two quantitative variables. And your correlation coefficient is always indicated by lowercase r. And if it's set equal to 0, then there is no relationship present. If it's set equal to 1, there's a strong positive relationship. And if it's set equal to -1, there's a strong negative relationship. So your correlation coefficient should always fall between -1 and +1. And we're not really going to focus on calculating this value right now. We're just going to focus on how to define the correlation coefficient if we look at a few scatter plots. So you can see that there are some positive and negative relationships here. And when you have a strong positive relationship, you want your R to fall between 0.8 and +1. You're never really going to have an R set exactly to +1 unless every single data point falls on your regression line. So in a strong case, you just want it to fall somewhere close to 1. In the moderate case, you just want your R to fall somewhere between 0.4 and 0.7, and you just adjust that value based on how strong the graph looks or how well the regression line fits the plot. When you see a ton of scatter and no direction, then you're going to have an R very close to 0, and it will have a weak relationship. And then once you have negative relationships, the sign is going to account for that. So your R, again, for a moderate relationship, now needs to fall between -0.7 and -0.4. And if you have a strong negative relationship, it can fall somewhere between -1 and -0.8. So the magnitude of the R is going to tell you the strength of the relationship, and then the sign is going to tell you the direction of the relationship. Now, the correlation coefficient is related to the coefficient of determination. The coefficient of determination is just a proportion of the total variation in y that is explained by x, and it's actually just r squared. So if you have an r squared equal to 0, this tells you you have a weak relationship. And if you have an r squared equal to 1, you have a strong relationship. And your r squared should always fall between 0 and 1, and you can actually think of this as a percentage. So let's say you have an r squared of 0.5. This is going to indicate that 50% of the total variation in y is being explained by x. So again, your coefficient of determination is just the square of your correlation coefficient. Now, one other thing we can assess for the strength are the residuals, and a residual is the difference between the observed value and the predicted value with your regression line and your plotted data. So if we look at a scatter plot and you have your data and regression line, the residual is the distance from your data point to the regression line, and it's just the difference between the observed value and the predicted value. So every single data point will have a residual. And one thing to note about residuals, if you sum all of your residuals up, they should always sum to 0. And so let's go ahead and plot these. Let's say you have your residuals, then you're going to plot them on your y-axis and the predicted values on the x-axis. And when you plot these points, your residual graph should have a lot of variation. There should be no trends. And so this will just indicate that there are no concerns raised when assessing the strength of the relationship. So when it comes to calculating all of the values discussed in this video, we can do that on a calculator, and you'll see that in a later video.